Welcome to this video where we are going to talk about quantities that we use in chemistry. And to illustrate what I'm talking about, let's go ahead and think about water. Water is H2O, and let's say we had 18 milliliters of water. That's not a lot of water. The question I'm going to ask is, how many molecules of water are in 18 milliliters of water? Now I know we haven't talked about molecules, and what we have talked about is atoms, but you can think of it similar as atoms, except for a bunch of atoms together. But how many molecules of water are in 18 milliliters of water? And the answer may surprise you. I'm going to go ahead and write on the board how many molecules of water are in 18 milliliters of water. And there we go. This is how many water molecules there are in 18 milliliters of water. And the reason why I bring this up is because, this is actually not even correct because I missed a zero. There's another zero at the end here. The reason why I bring this up is because this is a very, very large number. In fact, it's so large that it's hard for us to even understand what this number is. And just to give you perspective, these are the thousands, these are the millions, billions, trillions, quadrillions. I have no idea what that is, and this is sectillion. And so I'm going to point at this one right here. This is billion with a B. This is trillion with a T. And I would argue that us as humans have a hard time comprehending a billion, let alone a trillion. But to really comprehend this is really hard for us as humans. It is a very hard number for us to even comprehend. There are so many atoms, there's so many molecules in just 18 milliliters of water that we can't even comprehend. And that's only in 18 milliliters. Imagine the whole ocean. And so what we're going to do is we're going to learn about a way for us to deal with these numbers in a more manageable way. And so what we're going to do is we're going to talk about the mole. Now this isn't the mole, the animal, or the mole that's on your face, or the secret agent that is, hidden inside of an organization. This is a different type of mole. So let's go ahead and talk about what a mole is. Well, to understand what a mole is, it's kind of similar to the word pair or to the word dozen. How many items are in a pair? There's 2. And if Sam had 28 pairs of socks, how many total socks did he have? Well, if he has 28 pairs and there's 2 socks in a pair, that means he had 56. Now, how many items are in a dozen? Well, there's 12. If Mr. Dado ate 6 donuts, how many dozens of donuts did he eat? Well, 6 donuts would be half a dozen. So we can write half, or we can write 0.5. But here's the thing. The word pair and the word dozen represent these numbers that are smaller, but we need a unit that's going to represent a larger number of items, and that unit is called the mole. And so the mole is a unit we use in chemistry for very large quantities. And notice what 1 mole is. 1 mole of anything is 6.02 times 10 to the 23rd atoms. And so that's how many items there are in 1 mole. And I did say atoms at the end, but it's anything. So if you have 1 mole of anything, you have that many of that thing. You have 6.02 times 10 to the 23rd. Now, that's kind of like if you had a dozen of anything, like a dozen donuts or a dozen eggs, you have 12 of those things. And so we, instead of writing this number out, we do write it in scientific notation. Now this number happens to be called Avogadro's number. And again, we usually write it in scientific notation. Now let's go ahead and talk about the different types of things we'll see right now. So we'll see things like atoms. So if we had a mole of atoms, we had 6.02 times 10 to the 23rd of those atoms. And we'll also see particles. If we had a mole of particles, it'd be 6.02 times 10 to the 23rd. And so particles can be a lot of different things. And so it could be an atom, it can be a molecule, it can be an ion, which we'll learn about later. But anyways, particles are usually very small things that we're talking about. So let's go ahead and use this concept. And this right here is the thing we need to keep in mind, that 1 mole is that many of that thing. Now, let's go ahead and take a look at some example problems here. What if we had 1 mole of Dalmatian puppies? Well, if we had 1 mole of Dalmatian puppies, what we would have is, well, again, 1 mole of anything is equal to 6.02 times 10 to the 23rd. And so if we had 1 mole of Dalmatian puppies, we would have this many of that. Now, let's go ahead and talk about this next one. So how many atoms are in 2.5 moles of sodium? Well, again, 1 mole is 6.02 times 10 to the 23rd. And so if we had 2.5 moles of sodium, what we can do is we can convert that, it into atoms. And we know 1 mole is 6.02 times 10 to the 23rd atoms. And if you were to type that into your calculator, you would get about 1.5 times 10 to the 23rd atoms. Now what I want to say is we have not learned how to do this yet. This is what we're going to learn right now. And so what I want to do is sort of point out a couple things about this setup that are going to be really important for moving forward. Let's go ahead and look at a couple examples here. Let's go ahead and look at 2x divided by x. When you have 2x divided by x, what is the answer to this problem? Well, what do the x's do to each other? The x's actually cancel out. And so this will end up being 2. Because if you ever have something on the top and the bottom, they cancel out. For example, what if we had 2 times 5 divided by 2? Well, notice how these cancel out, and we're left with 5. And so the same thing is true with units. What if we have moles over moles? Well, if you have mole over mole, they cancel out. And what we're going to be really focusing on is this concept right here. What we're trying to do is when we are trying to convert between units, we're trying to cancel out those units. And so let's go ahead and go back and look at the problem we just did to see what's going on. And so if you take a look at this problem right here, you'll see that, notice how we have moles on the top here and moles on the bottom. And what ends up happening is they cancel out. So when we have 1 unit on the top and 1 unit on the bottom, they cancel out. And what I'm going to say is, what we're going to learn today, again, we haven't learned this yet, so just sort of try to follow along, and then when we learn it, I think it'll make a little more sense. What we're trying to do is we're trying to cancel the units out so that we get the right number. So how many moles of kittens do you have if you have this many kittens? Well, again, this number right here, 1 mole is equal to that number, so we would have 1 mole of kittens. Now the next thing we want to talk about is we want to talk about what is called the molar mass. And what I want to ask you is, if I have a dozen eggs and a dozen donuts, what do I have more of? Well, I have the same number of each, because a dozen eggs is 12 eggs and a dozen donuts is 12 donuts. I have the same number each. However, do they have the same masses? And the answer is no. So the eggs might weigh less or more, and so it depends on how big your donuts are. But let's just say we have a big donut. Well, then the donut would have a larger mass, and so a dozen donuts would have a larger mass than a dozen eggs. And so the same thing is true with molecules and atoms. You can have a mole of carbon and a mole of silicon, and you'll have the same number of each, because a mole is 6.02 times 10 to the 23rd. However, they'll have different masses. And the way we figure out the mass is by actually looking at the periodic table. If you look at the periodic table, you'll see this information right here. And this here is actually called the molar mass. This is the amount of grams that's in 1 mole. Now this also happens to be the average atomic mass, which is what we learned last unit how to calculate. And so the number that's on the periodic table, again, is how many grams there are in a mole. So let's go ahead and talk about how we can solve these problems. And what I'm going to do is I'm going to write a flowchart, and this flowchart is going to be so important for many things in this class. We're going to be using this flowchart almost every unit for the whole year. So let's go ahead and write this flowchart. If we have grams, we can take the grams and convert it to moles. And if we have moles, we can take the grams and convert it to, I'm going to say, atoms. So we're going to call them atoms at this point. Now what I will say is later we'll change the atoms to molecules or particles or whatever, but for now we're only going to be dealing with atoms. Now what I want you to do is look at this flowchart. If we have grams, we can go from grams to moles. We can go from moles to grams. So we can go forward and backwards. We can start with atoms and go to moles. We can go from moles to atoms. And so we can start anywhere on this chart and go anywhere. So we can start with moles and we can go to grams. And so there's not a particular direction that you have to go. Now, when we go between moles and atoms, what we're going to do is we're going to use Avogadro's number. Avogadro's number. And Avogadro's number is 6.02 times 10 to the 23rd. By the way, what letter does atom start with? It starts with A. What letter does Avogadro start with? It starts with A. So that's something to help you remember that. Now, when we go between grams and moles, what we're going to use is what is called the molar mass. And we get the molar mass from the periodic table. So I'm going to put PT there for periodic table. And so this is the flowchart that we will use for all problems. I would make sure that I have this flowchart written down, ready to go for all of these problems, because it will really help you moving forward. So let's go ahead and do this practice problem here. If you have 4.6 moles of titanium, how much is the mass of your sample in grams? And so let's go ahead and think about this problem. We're starting with moles and we're going to grams. So let's go ahead and look at the flow chart. We're starting with moles and we're going to grams. And the first 3 steps to all of these problems are the same, and I'm about to write these steps down. Step 1 is to write what is given. So write what is given. That is the first step you do. So let's go ahead and do that. So let's write what's given. Well, we are given 4.6 moles of titanium. Step 2 is to multiply by an empty fraction. You're going to multiply by an empty fraction, and we're eventually going to fill in that fraction. So let me show you what that means. We're going to multiply by an empty fraction. So that's step 2. Step 3 is the units you start with. The units you start with go on the bottom. So go ahead and take a moment to write that down. So let's go ahead and talk about what that means. So what units are we starting with? Well, we're starting with moles. And whatever we start with will always go on the bottom. Always. It does not matter what we start with. We start with atoms, goes on the bottom. We start with moles, on the bottom. If we start with grams, on the bottom. And so we go like this. So those are the first 3 steps to every single problem. After that, we have to sort of think about where we're going. Well, what is the problem asking for? The problem is asking for grams. And so we can go from moles to grams. Now, what happens is, because we have the mole on top and the mole on the bottom, what happens is they cancel out. So these will actually cancel out. And now we're left with our setup here. And so what I want to point out is, notice how we set the units up without putting in any numbers. And now that we have our units set up properly, now we will fill in numbers. It is going to be very, very, very important. I cannot stress this enough. Please listen. Please listen. Set your units up before you put your numbers in. Because I've been teaching this for 7 years now. I know the mistakes that you make, and the mistakes that a lot of people will not make those mistakes if you set your units up first. So if you set your units up first, you will not make a lot of common mistakes that people make. So now that we have our units set up, what we want to do is we want to fill in our numbers. And what I will say is a 1, so within the fraction, a 1 will always go in front of moles. You will always put a 1 in front of moles, because we know that 1 mole is equal to Avogadro's number, and we know that 1 mole is equal to the molar mass. So 1 mole is equal to Avogadro's number, 1 mole is equal to the molar mass. And so we'll always end up putting a 1 in front of moles. Now let's go ahead and take a look here. We're going between moles and grams here. So what do we use when we go between moles and mass? When we go between moles and grams? What we use is the molar mass from the periodic table. And if you take a look here, we're dealing with titanium, and we happen to have the symbol from the periodic table there, or the little thing from the periodic table there, and this right here is the molar mass. And so again, when we go between grams and moles, we use the molar mass, which is 47.90. And now we use our awesome calculator skills to type it in and get the right answer. Now, that's the answer you get, except there's something wrong with it. Before I talk about what's wrong with it, though, I want to point out is, in this class, you will always go to 2 decimal places. So make sure you just go to 2 decimal places for this class. But what's wrong with it? Well, we're missing the units. What units are we left with? Well, moles are canceled out. What are we left with? We're left with grams. And so this is your answer. And then we box it and we put a smiley face. All right, let's go ahead and talk about this next one, all right? So if you have 4.5 times 10 to the 24 atoms of titanium, the question is, how many moles of titanium do you have? So we are starting with atoms of titanium, and it's asking for moles. And so if we think about this flow chart, we're starting with atoms, we're going to moles. So notice how we can go in any direction here. Now, step 1, if you take a look, step 1 is to write what's given to you. Okay, well, what is given to us? 4.5 times 10 to the 24 atoms. All right. Step 2 is you multiply by some empty fraction. So we're going to multiply it by some empty fraction. Okay. Step 3, the units you start with go on the bottom. Well, we're starting with atoms, and so atoms go on the bottom, because what ends up happening is the atoms cancel out, and that's what we want. We want to cancel the units out. Now we're going to go from atoms to moles. What always goes in front of moles? A 1. And then if we take a look, what do we use when we go between atoms and moles? What do we use? we use Avogadro's number, which is 6.02 times 10 to the 23rd. Now, all we need to do is use our fancy calculator skills to figure out this problem. And what I want you to do is, I'm going to write the answer on here, but I want you to actually take a moment to type this in the calculator to make sure that you know how to type this in. Very important. And what we end up with is 7.47 times 10 to the, oh, nope, no times 10. Just 7.47. And again, we're going to go to 2 decimal places. What are we forgetting? What are we missing? We're missing the units. What units are we left with? We're left with moles. And then we need to box it. Smiley face. All right, let's go ahead and do this last one here. All right, so it's asking for moles, how many moles, and it's giving us grams. Step 1 is you write what's given to you. Step 2, you multiply by a fraction. Step 3, the units you start with go on the bottom. Now, again, the first 3 steps are always the same. This is something that is very easy to do. It's very easy. You write what's given to you, you multiply by a fraction, the units you start with go on the bottom because we want to cancel these out. And so now we can go from grams to moles, because if you take a look, we can go from grams to moles. So again, I'm going to really emphasize this. Notice that I'm setting the units up before I put numbers in. What always goes in front of moles? A 1. Again, what always goes in front of moles? A 1. And when I say what always goes in front of moles, I mean within the fraction. So you can totally have something that's not a 1 in front of moles that's not in the fraction. But I'm talking about within the fraction, we always have a 1. So notice 1 mole, 1 mole, 1 mole. Now, what do we use when we go between grams and moles? When we're going between grams and moles, what do we use? We use the molar mass, which we can find on the periodic table. And again, we're dealing with titanium, which happens to give us the molar mass right there. And so it's this number right here that is the molar mass. So the atomic mass is the molar mass. So again, what that is the amount of grams there are in 1 mole. And all we need to do is type this into our calculator and then we'll get our answer. And again, we're going to go to 2 decimal places. The grams cancel. We're left with moles. And we box our answer. And one more smiley face. There we go. And maybe this guy has some bushy eyebrows. All right, and that's it. So again, what we're doing is we learned about the mole. The mole helps us deal with these large numbers of atoms. And instead of dealing with these large number of atoms, we can make them into a more manageable number. Eventually, we will use moles in many of our calculations in the future. This is a concept that will be used throughout the entire year. It'll be the last day of school and we'll still be using it. So make sure that you got it down, and if you need any tutorials, if you need any help, let me know, email me, and I will definitely help you. You guys have a great day.